Hello, everyone. Mr. Minnick's my name. Math is my game. And before we get started with today's lesson, I got a few shout outs by request. Sarah DeSalvo would like to give a shout out to Natalie Hall. And there's some other shout outs that'll be coming throughout the video. But Mr. Minnick gets a shout out. And anyway, Chapter 8, Section 5 Add and subtract rational expressions. I'd like to give a shout out to my first period class for enduring the recording of these videos. They usually do a fine job, so I applaud them. So Chapter 8, Section 5, adding and subtracting rational expressions. The second line of that title, instead of rational expressions, we could say fractions. The only thing is our fractions aren't going to look like just numbers. There's going to be a lot more to them. So there's going to be polynomials in them and whatnot. You can see the key vocabulary: complex fraction. Remember, that's a fraction where there's fractions in the numerator and denominator. Those are going to be something like 1 over x plus 5 over 3 plus 6 over x minus 2. Those are the kind of things that we're going to be dealing with before the dust has settled. So let's just get right to it. We know how to add and subtract fractions. If the denominators are the same, we leave the denominator the same. Some people, they want to double up the denominator, but if the denominators are the same, it stays the same. So this really shouldn't be any surprise. Really not a whole lot here going on to worthy of writing down. It's just saying if the denominators are the same, we just add or subtract the numerators and the denominators stay the same. Make sense? So on a 1 to 10 scale, these are the 1s and 2s. These are the easy ones. So if we look at example 1, number A, I know A is not a number, but oh, by the way, CJ Gage gets a shout out too. On example number 1, part A, we've got a denominator of 4x. So our denominator is going to stay 4x. And in the numerator, we just add the numerators. So what's that going to be? What over 4x? 10. So you might think you're done there, but you're not. Now we got to back up to the last section. In the last section, the directions were factor and cancel or reduce. And the deal is on this particular one, we're not done because 10 and 4 are both even, so we can simplify this a little bit more. So they're both divisible by 2, so this is going to end up equaling what for our final answer? 5 over 2x, and that's it. 5 over 2x. Got the answers underneath those red dots in case you're wondering what those are all about. So if we divide it by 2 there, we get 5 over 2x, and that's it. Part A, we cool with that one? Part B, same thing. The only difference is we're subtracting. Okay, but the denominator is the same. It's x plus 6, so the denominator stays x plus 6. And up top, we have 2x. We're taking away 5, so it's 2x, take away 5. And that's it. And that's it. In the last section, we looked at the fact that you might think, well, x over x is 1. Well, x over x is 1, but we don't have x over x. We have 2x minus 5 over x plus 6. We have a quantity over a quantity, and that can't simplify any further. We doing all right so far? Okay. So we better not waste too much time on the easy ones because there's going to be some tough ones, believe it. So I think we could skip right over all these. So here's where it gets a little tricky. They say if the denominators aren't the same, you have to make them the same. And we've seen that before, so let's jump into one of these. Well, before that, they're going to build up this idea of LCMs. So I better do that too. First of all, we probably better talk about multiples. We probably ought to talk about factors. When people find out that I'm a math teacher, the most frustrating thing about it, when people out in the world, not in school, when they find out I'm a math teacher, you know the first thing they do to me? They don't ask me about a math problem. The first thing they do is They apologize for having been so bad at math in school. I said, you don't have to apologize if you were bad at math in school. I'm sorry you were, but you don't have to apologize for it. I don't feel bad about it. I mean, I wish, well, anyway. All right. But anyway, when people, the second thing that happens when people find out I'm a math teacher is they ask for tutoring. And I do tutor. I'm expensive. 30 bucks an hour is my rate. I haven't tutored in a while. Might have to go up to 40 bucks an hour. I don't know. But anyway, this is a question I get all the time. 5th and 6th grade parents, they ask me all the time. My student is not understanding the difference between multiples and factors. Multiples of a number n are as follows. The multiples of a number n are as follows. 1 times n, and 2 times n, and 3 times n, etc. So if we look at a specific instance, 4's multiples, bless you. 4's multiples would be 4, because that's 1 times 4. And then 2 times 4 would be 8, and 3 times 4 would be 12, and 4 times 4 is 16, and 5 times 4 is 20, and 6 times 4 is 24, etc. Okay, so when you're finding multiples of a number, that's what they are. And you probably already knew this, but a lot of people confuse the idea of multiples and factors. Factors of a number are integer pairs whose product is the number, whose product is the number. So a nice example of that might be 8. 8's factors. 8's factors. Whoa. I don't know what I wrote. 8's factors are 1 and 8, because that's one pair that's product is 8, and 2 and 4 is another pair. Right? So a lot of people get the idea of multiples and factors confused, because in math class we throw around 3-letter acronyms like they throw horseshoes at the county fair. Anybody ever go to the county fair and watch horseshoes? That's a good time. I like it because being close counts there. Nobody goes to the county fair to watch horseshoes, though? I go to watch the tractor pulls. And to the dairy barn to get a milkshake, because their milkshakes at the dairy barn are where it's at. And I'll be honest, I people watch at the county fair. I'm not going to lie. I just sit up in the grandstand and watch people. All right. So you're going to be asked to find an LCM. And you know that L stands for least common multiple. So in 6th grade, you had to find LCMs of numbers. Well, this isn't 6th grade anymore, son. And I'm sorry if any of the ladies take offense to that. I said that to my wife the other day. I said, you better step up, son. She raised her fist. She was about to. So the LCM of 4 and 7, this is where your 6th grade teacher told you these are easy to do. You just do what with the 4 and the 7? You just multiply them. Now the interesting thing about 4 and 7 are relatively prime. I know that seems like a really complicated word. All it's saying is they don't have any factors in common. What relatively prime means is they have no common factors. They have no common factors. So if two numbers have no common factors, they're said to be relatively prime. And in that context, your 6th grade teacher's right. You just take 4 times 7, which equals 28. And 28 is the LCM of 4 and 7. Okay? The problem is when things aren't relatively prime. When things aren't relatively prime. So if we look at another example, real similar, what if we look at the LCM of 4 and 16? Here, if you did your 6th grade teacher's method, you would find a common multiple, but you certainly would not find the least common multiple. So in the context when these things are not relatively prime, when they're not relatively prime, it's not just a simple matter of taking 4 times 16 and getting 64. That's not what you do. That's wrong. 64 is a common multiple, but it's not the least. In the case of this one, we got to look at each number's multiples. We said 4's multiples are 4 and 8 and 12 and 16 and 24, and 20 and 24 and 28, and I probably should have stopped a while ago, but I'll go one more time, 32, etc. And when we look at 16, 16's multiples are 16, 32, 48, 64, but we're looking for the least common multiple. What is it? It's 16. It's 16. So in this particular case, 16 is the LCM. Maybe we should try one more with numbers. Let's try one more with numbers. Let's try to find the LCM of 20 and 32. Yeah. Now the calculator can do these for you with numbers. Matter of fact, I'll start my TI Inspire. It's going to take a while to load. You guys know how it goes. So when you have something like this, maybe this will help us when we get to ones with variables. 20's multiples are 20, 40, 60, 80, 100, 120, 140. This is probably going to take a minute to find, isn't it? 32's multiples are 32, 64. I have a feeling once I get to 32 times 5, I'm going to get something that's going to work. Maybe. I hope. 32 times 3 is 96. 32 times 4, that ends in an 8. Carry the 1. Is that 1? No, you don't carry a 1. That's 128. And 32 times 5, that ends in a 0. Carry the 1. Is that 160? 160. So 160 ends up being that LCM, right? So sometimes finding LCMs is tough with numbers. So if it's tough with numbers, imagine if we throw variables and variable expressions into the mix. Maybe we should have tried this 20 and 32 example a different way. Maybe we should have broken down 20 and 32 into their factors, into their prime factors. This is 2 times 2 times 5. And this is 2 times 2 times 2 times 2 times 2. So maybe if we just look at the factors of each of these, this has 5 2's in it. This only has 2, but that other one had 5 in it. So maybe our LCM is going to be this 2 times 2 times 2 times 2 times 2 times the factor that this thing has that this other thing didn't, times 5. Wait a minute, that did it, didn't it? If we take those, 32 has all these in it. 20 only has 2 2's, but this one has 5, so we need all 5 of those 2's. And 20 had a 5 in it, 32 didn't, but we need to represent that 5. And if we do that, that ends up being 160. And that's how we kind of find the LCM of those. We break it down into its prime factors, and we have to represent every single one without representing them more than we need to. It's kind of a difficult concept to explain. Kind of a difficult concept to understand, if I'm being honest. So on the calculator, just to show you about the LCM, we got LCM, left parenthesis, what was it, 16 or was it 16? 20 and 32, thank you. 20, and 32. So the calculator can find those. Just with numbers. So what's going to happen now is they're going to say, okay, hotshot, find the LCM of these variable expressions. So my suggestion to you is break these things down into their individual factors. We could factor a 4 out of that. That's x squared minus 4, and that factors into 4 times x plus 2 and x minus 2. That's how that one thing factors. The other expression, we should be able to factor a 6 out of. So that's x squared minus 4x plus 4. So that ends up being 6 times x minus 2 times x minus 2. So really what we're comparing then is this and this. So kind of like with the 20 and the 32, we got to represent everything. But we don't want to represent it more than we have to. Maybe we should look at the 4 and the 6 first. As far as the numbers go, what would the LCM of 4 and 6 be? Not 2. That's a factor. 12. An LCM is going to at least be as big as the biggest number, right? So the LCM of 4 and 6 is 12. So now it's just a matter of representing everything. So if we look over here, we've got an x plus 2 in this factor here, right? That's got to show up in our LCM. So x plus 2 is going to show up. Now, if we continue to just look at it, and sometimes just looking at it is the right thing to do. If we look over here, there's an x minus 2. If we look on the other side, and that's totally not working the way I wanted it to. If we look over here on this other side, this has x minus 2 twice, doesn't it? We got to represent what's there. If we go back to that last example with the 32, we had that 2 times 2 times 2 times 2 times 2, right? And we had to represent all 5 of them. So on this example, we're going to have that x minus 2 just once or twice. Got to have it twice. So we got the 4 and the 6 are taken care of. The x plus 2 is taken care of. And the x minus 2s, both of them here, are checked off, and we got it. That's it. That's how you find an LCM with variable expressions. You got to represent. There was this movie back in the 90s, one of my favorite basketball movies of all times. It was called Sunset Park. Do you guys know Rhea Perlman? She was Carla on Cheers. Anyway, she was a basketball coach of an inner city school. It was called Sunset Park. It was awesome. The theme song was Sunset Park, what time is it? And they used to say, it's time to get live, it's time to represent. So, all right. Air Bud was okay, but wasn't one of my favorites. Air Bud wasn't one of my favorites. I liked Hoosiers. That's a good one. Hoosiers was a good one. So, all right. The reason you have to find LCMs is because an LCM is how you find an LCD. Remember, an LCD is the LCM of the D's. We said that yesterday. What'd you talk about, Willis? So what I've got here is 7. Well, I guess I better find the LCD. So to find this LCD, I'm going to be looking at 9x squared, which is 3 times 3 times x. And this other thing here, if I break that down, that's 3x times x plus 1. So what's my LCD going to look like? To find my LCD, I'm going to be comparing this and this. So as far as the numbers go, what's the numeric portion of it going to look like? It's going to be 3 times 3, right? I got to have 2 3s, right? So the LCD is going to be 3 times 3. What else? It looks like I'm going to have at least an x in it. Or do I need 2? Got to have 2, because this has, the one on the left over here has 2 of them. So I'm going to need an x and an x. And then that 3x times x plus 1, that's got an x plus 1 in it, and I got to represent that. So also I got to have an x plus 1 in it. So my least common denominator is going to be all that. Wow. Mm. Yeah, that's going to be what, 9x squared times x plus 1? Yeah. So I'm going to kind of leave this in factored form. Um, what I'm going to have to do, this 7 over, I guess I could leave this as 9x squared. So the 7 over 9x squared, I'm going to have to take that, and if I look at it, I got the 9 covered, I got the x squared covered. I'm going to have to multiply that by x plus 1, right, to get the denominator to look the way it's got to look. Does that make sense? Uh-oh. No, we're cool. Okay, it's good. So we got to multiply that by x plus 1. But if I do that, I just screwed up this whole fraction. I just changed the value of this fraction. So I got to also multiply the numerator by that, don't I? So I also got to multiply the numerator by x plus 1. Okay. So then the other term, remember terms are separated by addition or subtraction. The other term, we said that that's 3x times x plus 1. What am I going to have to multiply that other term by to get the denominators to look the same? To turn a 3 into a 9, don't I have to multiply by 3? And to get that x squared, I'm going to have to multiply by what, 3x? So I'm going to have to multiply by 3x, but if I multiply just the bottom, that's going to screw that up. I got to multiply the top too. Okay, so I got to multiply by 3x over 3x. Does that make sense about getting the denominators the same? Okay. So when I do this, my denominator, the whole denominator, is going to be this 9x squared times x plus 1. That's going to be my denominator. My numerator, if I use the distributive property, I'm going to get 7x plus 7 plus 3x squared. Now, you might think we're done, but we're not even close. What do you know about polynomials? They are supposed to be written in what kind of form? Standard form, which means that the terms are written in descending order by degree. So we should write 3x squared plus 7x plus 7 over this 9x squared times x plus 1. Now you might think we're done. If the numerator factors, remember the last section how we had to factor and cancel? If the numerator factors, we might have to cancel something out. I don't know that it's going to. If it were going to cancel out, and I don't know if this is going to happen or not, but it would have to factor into x plus 1 something, right? And if that were the case, this would have to be a 3x, and this would have to be a 7. But that doesn't factor that way, does it? That doesn't factor that way. So we're done. So could you reduce the 3x squared with the 9x squared? Again, because of the plus 7x plus 7, you can't. Yeah, you can't reduce just those. Yep. Good question. Whoop. So that's it. That's our answer. There are going to be some of these that might factor and cancel later. Any questions about that one? Okay. Well, let's look at one more like that. And then the last example we're going to get into, we'll probably look at 2 complex fractions, but so here's another one. This time we're subtracting, so it's a little different when you subtract, and we'll get to that in a minute. So this denominator is 2 times x minus 1. My numerator, of course, is this x plus 2. I'm subtracting. This other denominator factors into x minus 1 times x minus 3. And of course, this numerator is negative 2x minus 1. So I want my denominators to look identical. I want my denominators to look identical. And If I look right here, there's a 2 there, right? But this other denominator, does it have a 2 in it? No. So I need to multiply at least by 2 over 2, right? So I'm going to multiply this by 2 over 2. Our denominator is entirely the same now. This one over here's got an x minus 3 in it, but this one doesn't. So guess what I got to do to this fraction? Multiply by an x minus 3 over an x minus 3. Now our denominators are the same. Now we got a lot of stuff to clean up. So if we go ahead and FOIL out that numerator on the left, that's going to be x squared minus x minus 6 over 2 times x minus 1 times x minus 3. And everything's going to be over the same denominator. And here's where things get messy. Here's where subtracting's not fun. I'm going to be subtracting all of the stuff that results from multiplying this out. So I'm going to put that stuff in parentheses. So if I multiply 2 times that negative 2x minus 1, what's that going to give me? Negative 4x minus 2. Good. So we'll go ahead and simplify that numerator because it can be cleaned up. So we still got x squared. But we have this minus x here, and we're minusing a minus 4x. If we minus 4x, what are we really doing? Adding. So it's minus x plus 4x, which is going to give us minus x plus 4x is going to give us plus 3x. Okay. And then we have minus 6. We have minus 6, and we're minusing minus 2. So that's like negative 6 plus 2. So what's that going to be? Minus 4. Keep in mind this is all still over 2 times x minus 1 times x minus 3. Now that numerator, I think 4 has factors that add up to 3, doesn't it? That numerator is going to factor. That numerator is going to factor. So that's going to be an x and a 1 and an x and a 4. This is a 2 times x minus 1 times x minus 3. Let's look at those signs. What's it got to be? Plus 4, plus on the 4, minus on the 1? Just like last section, can we cancel anything out? The x minus 1's cancel. So our final answer is going to be x plus 4 over 2 times the quantity x minus 3. Wow. That's kind of like running the 2-mile in track. After about the 5th lap, you're like, is this over yet? Anybody ever run the 2-mile in track? I did. Not my favorite event. I always did good at it. Just didn't like it. The easier way to do this? Well, I've tried to sell people on the TI Inspire CAS before, so I could give a shout out to the TI Inspire CAS and show you that it can do these. It's going to take a minute to load. Are there any questions about any of the steps along the way of this example before we look at how awesome of a calculator the TI CAS is? The TI Inspire CAS? So we're going to be looking at complex fractions in a minute, and as complex as they might sound, they're actually not that bad. So we'll see how well the TI Inspire CAS handles this one. It's just about to load. Takes a while to type it in, but it also takes a long time to write that problem down. That was a big problem. Speaking of which, you guys know why math teachers don't have many friends, don't you? Before you can find out how come math teachers don't have many friends, you got to know why they're always so upset. You know why math teachers are always so upset? Because they have a lot of problems. And you know why they have no friends? Because they share their problems with their friends. So that's the way it goes. So we're subtracting a fraction. Let's see. Negative 2x minus 1 up top. And the denominator was x squared minus 4x minus 4x plus 3. So there it is. You see how fast that was? What did that take? A split second. The exclamation point's talking about the restrictions, saying, I did this as well as I can. Your teacher probably wants to know something else, like the fact that if we had to talk about restrictions on this, x could not equal 1, x could not equal 3. So, all right, well, here we go with this complex fraction business. Complex fractions. I'm going to put this on a new page. I don't like the way they explain it. There actually are a couple of different ways to do this one, but would you look at that? So if we were to identify our denominators, this is a denominator, this is also a denominator, and this is a denominator. So what we need to find is the LCD of the D's. The LCD of the D's. So it looks like we're going to have an x plus 4, right? And we also need what? We also need an x. So what we're going to do is multiply the numerator and the denominator by that. So we're going to multiply the numerator by x times x plus 4. We're going to multiply the denominator by x times x plus 4. So when we do this, you got to be really good at cross-canceling. If I could get out my screen for a minute and just look at the numerator. I don't know if you get this or not, but this x plus 4 and this x plus 4, are those going to cross-cancel? You better believe it. Those are going to cross-cancel. So what's going to end up happening then is we're going to have 5 times x. We're going to have this 5 times this x, and that's going to make up our new numerator. What's the question? Wouldn't there be an x in the bottom? Well, the deal is what's happening in this numerator here is we're taking 5 over x plus 4, and we're multiplying that by x times x plus 4. So if we make a big fraction, the x plus 4's cancel. Yeah, and all that's left is that 5x. Okay? So if we look at the denominator then, as far as this cross-canceling, this first term, this x plus 4 is going to cancel this x plus 4 in the first term. So that first term is going to be 1 times x, which is just going to be x. And this next term, the second term, this x here is going to cancel out with this x here. So the other term in the denominator is going to be what? 2 times x plus 4. It's really hard to keep all that straight, what's going on there, but that's what's going on there. Okay, again, if you're not clear about that, I'll write that off to the side, what's going on there. We have 1 over x plus 4, and that's being multiplied by x times x plus 4. So the x plus 4's cancel. And then added to that, we've got 2 over x being multiplied by x plus 4, so the x's cancel. Okay. So if we simplify this then, we can't do much with the top. The denominator is going to be x plus, we got to use a distributive property here. What's that going to be? 2x plus 8. So we get 5x over 3x plus 8. That's it. Can't cancel the x's because not every term is divisible by x. And that's it. 5x over 3x plus 8. Let's see how we did. I think the answer's over here. Yeah, 5x over 3x plus 8. We'll try another one of those. One more. That's it. One more. Uno más, por favor. Take your pick. What do you want, 11, 12, or 13? 13? Okay. Welcome to the new page. To the new page. Okay, so we got to multiply the top and the denominator by the LCD of the D's. So what's that going to look like? X plus 5 times x minus 3. Good. So this first time, this x plus 5 is going to cross cancel that x plus 5. So in the numerator, it's going to be what? 3 times x minus 3. So we're done with the numerator. In the denominator, for the first term, this x minus 3 is going to cancel that x minus 3, right? So the first term in the denominator is going to be 2 times x plus 5. And then this other term, the x plus 5s are going to cancel. And 1 times x minus 3, isn't that just x minus 3? Okay. All right. Oh, sorry. There we go. So we're just about done. We use a distributive property, combining like terms that might need combined. So we're going to get 3x minus 9 over 2x plus 10 plus x minus 3. So that's 3x minus 9 over 3x plus 7. Could those 3 x's cancel? No. So I see what you I see exactly what you're asking. The question is, could we cancel this x plus 3 and this x plus 3? The only way we could do that is if this term here had an x minus 3 in it, and it doesn't. But I was wondering that myself too. I'm glad you asked. Yeah, you can't cancel this x minus 3 with this one because this other term doesn't have that as a factor also. Good question. Really good question. Well, good news, bad news. Bad news is there is homework tonight. Good news is since most of the problems take up so much space and in a fair amount of time, if I'm being honest, there's not that many exercises for you to try. All week long, I've been given the Mathway speech. I don't think Mathway is a bad thing. I think getting answers for the sake of getting answers on Mathway, you're not learning anything. And I could tell when you take the quiz who's using Mathway or who's copying answers off of other people's papers. So anyway, that's it. That's all I got. It's been real. It's been fun. I hope it's been educational. And I'll see you next time.
Good.